Hello viewers, welcome to my channel IIT Olympiad and AP Physics with Ambarish. And in this video, I've brought another exciting challenge in the Olympiad workout series, and the title of the challenge is the Drowning Cube Challenge. So what's the challenge? A cube having body diagonal of length capital L and density 4 rho or mass 4m is being slowly lowered into a very wide pool containing two liquids as shown. Calculate the work done by the tension in the process from the moment the bottom vertex of the cube is touching the surface of top liquid to the moment when the bottom vertex just touches the bottom of the lower liquid. So now here is the cube and we are lowering it with help of a thread, or you can say a rope. And right now initially the bottom vertex of this cube is just touching the surface of the upper liquid, and then we are going to lower it gradually by extending the string all the way to the bottom, so that the vertex of the cube is going to touch finally the bottommost point of the this tank of the liquid of density 2 rho, and it's going just to touch the bottom surface of the pool. Okay, and in this process we have to find the work done by tension in the entire process. Okay, so if you want, you can try out this challenge for 5 to 10 minutes and then see my solution right after this. Alright, so let's look at the solution. Now one of the conventional approaches in this kind of questions is that students try to take an element and then find the buoyant force, and then they try to integrate the buoyant force. But in this, the problem is that the element is of a very strange shape, and the integration is going to be like an Atmahatya. So that's definitely not the best way of doing it. So let's see an alternative way of doing this question elegantly. So what we can do, so we know that the work done is equal to change in mechanical energy of the system, and this is what we are going to use, the work energy theorem, you can say, or the conservation of mechanical energy principle, or the change in mechanical energy principle. So this is what we are going to use. So now see what's going to happen. As you are going to lower this cube, what will happen? Suppose this cube goes and sits in the liquid 2, then some liquid 2 is displaced. And where does the displaced liquid 2 sit? So the displaced liquid 2 will sit on the top layer of the liquid 2 right now. Some molecules will go to the top layer because this much liquid has been displaced. Now when these molecules go to the top layer, but the top layer is already occupied by liquid 1, so there are some molecules already sitting of liquid 1 in the top layer. So where do those particles go? So those particles get displaced, and then where do those particles go? You can put those particles on the top of liquid 1. Okay, particles are interchangeable, so it doesn't matter if the whole thing shifts by one particle or the lower particles go to the top particle. You know that potential energy only depends on configuration. Alright, so let me make things more concrete for you, and let me talk in very simple and crystal clear terms. So let's see. So this is the final configuration of the cube. So cube is completely drowned in liquid 2 and some liquid has been displaced. So whatever is the displaced liquid, where does it go? It goes on the top of liquid 2. It forms a thin layer because the pool is very wide, so layer is, you can say, one particle thick, and it's going to be a very infinite size kind of layer. And center of mass of this liquid was initially over here, and this liquid now has been shifted by a distance L by 2. So we can say that center of mass of this much liquid has shifted by an amount L by 2 equivalent to the volume of the displaced cube. Okay, and what will be the mass of the displaced volume? Because cube density is 4 rho and liquid density is 2 rho, so that means 2m mass is displaced by a distance L by 2. Alright, so this is the change. This will be used for finding the change in potential energy of liquid 2, as if this much water is going to the top layer. Alright, water or liquid, whatever. Okay, now what's happening with the liquid 1? Let's see. So this much of liquid 2 went to form a layer on the top, but then on the top already there were molecules of liquid 1, so top of this is actually bottom of liquid 1. So that means what? These particles of liquid 1, they will have to be displaced. So either you can shift the entire liquid 1, or you can just imagine that these particles which are displaced from top are forming a layer at the from the particles which are displaced from bottom of the liquid 1, they are forming a layer on the top of liquid 1. So that means what? We can say that this much volume is displaced through a distance L. And what will be the mass of this much volume? You know that the density is rho and this volume is same as the volume of the cube. So that means what? The mass that is shifted from here to here, that is m. because cube is 4m, so 2 row forms for the same volume 2m and row forms for the same volume m. Okay, so and we'll be using this information for calculating change in potential energy of liquid 1. So now let's write it in the form of equation. I hope it is very lucid. So now delta W is delta PE2, delta PE plus delta PE1 and plus delta PE of the cube. So what is delta PE of liquid 2? So that's mass of this into G into L by 2. What is delta PE of liquid 1? That is mass of this much liquid 1 into G into L. And what is delta PE of the cube? So cube, you can see the cube is initially at the top with this vertex touching here, and this vertex is finally going to get displaced through a distance 2L. So that means what? Cube is losing a potential energy of 4 mgl. So let's write this in the form of equation. So what's the total work done? So change in potential energy of liquid 2, that is 2 mg, because this mass is going to be 2m as I said. So 2 mg into L by 2. So center of mass gets displaced by L by 2. So this liquid is going here. The change in potential energy of liquid 2. Now for liquid 1, this much mass should be m because this density is rho, and this m mass is getting shifted to the top layer, you can say. Okay, so mg into L, and for the cube it is 4 mg and the distance is 2L. So this is the total change in potential energy of the system, and this must also be the work done by the tension. So if you solve this, this comes out to be delta W is minus 6 mgl. So that's our final answer, and I hope all of you like this video, and if you did like this video, please do subscribe to my channel if you have not already subscribed, and please share this video as much as possible with your friends. If you're a student, you can share it with your peer group who are preparing for Olympiads or IIT JEE. I'm sure this video will be very helpful in solving some fluid mechanics questions, and please do give it a thumbs up. That's all for this video. Thank you for watching, and see you in the next video.